Okay, let's dive right into this. Welcome to today's Explainer, where we are going straight inside the world's deadliest volcanoes. I mean, when we talk about forces of nature, there are very few things that command absolute respect quite like these incredibly powerful formations. We're not just going to skim the surface here. Beneath those tranquil, dormant mountains are massive, superheated magma chambers and shifting tectonic plates. So we're going to pull back the layers of the Earth's crust to understand the real science of how all that subterranean fire actually translates into surface-level devastation.
To even begin to comprehend the sheer massive size of these geological giants, we literally have to think on a cinematic scale. Think about a massive 16:9 widescreen ratio, right? A standard constrained view just cannot capture the immense volume of these things. We're talking sweeping calderas stretching for dozens of miles and towering ash plumes that pierce the stratosphere during a major eruption. This wide, expansive frame really mirrors the vastness of the landscapes they dominate, and honestly, the sheer magnitude of the threat they pose. These are forces that can bury ancient cities in a single afternoon and alter global weather patterns for years.
So how do these powerful volcanoes actually form? It's one thing to see the terrifying results on the surface, but the real journey begins when we look deep into the hidden mechanics of their creation. How does the Earth literally build a mountain capable of such terrifying power? Well, it involves the relentless, grinding collision of tectonic plates at subduction zones, where deep mantle plumes pushing scorching heat upwards right through the crust. It's a process of unimaginable pressure and friction happening right beneath our feet.
Let's move on to the anatomy of a volcano and see exactly how this powerful formation builds over time.
Now, what's really interesting here is how we define the deadliest volcanoes. We're specifically talking about powerful natural formations capable of immense and catastrophic destruction. It's that combination, powerful formation plus catastrophic destruction, that makes these completely different from a standard mountain. Driven by intense heat, trapped dissolved gases, and thick, viscous magma, they are basically living, breathing engines. It's actually the high silica content in the magma that acts like a pressure cooker. It stops the gases from escaping easily and turns a simple geological feature into a ticking time bomb just waiting to go off. Breaking this down educationally, understanding this threat really happens in three distinct phases. First, we learn the science, the macro-level geology of shifting tectonic plates, subduction, and the mantle dynamics fueling the whole system. Second, the powerful volcanoes form. This is the slow, step-by-step gathering of immense pressure as magma forces its way up, inflating chambers over countless years, sometimes even centuries. And finally, step 3, destruction. That's the terrifying climax where that hidden pressure overcomes the rock above it and is violently, suddenly released into the atmosphere. And that brings us to the exact moment these dormant giants wake up, unleashing the destruction and the true impact of their power. This brilliantly illustrates the ultimate paradox of these natural wonders. On one hand, you have the slow, painstaking, almost invisible process of formation, which takes millennia of quiet, relentless geological pressure. But then, on the flip side, you have the rapid, overwhelming destruction they can cause. In just a matter of minutes, all of that slowly accumulated energy is discharged. We're talking superheated pyroclastic flows racing down slopes at hurricane speeds, and massive lahars, which are essentially volcanic mudflows, literally wiping out everything in their path. It is a stunning contrast between the slow build of creation and the blinding speed of devastation. Now let's shift gears a bit and look at the aftermath and global impact, doing a quick educational breakdown of the consequences. So, the crucial point here, when we look at these elements side by side, is the sheer scale of the transformation. The formation relies on hidden mechanics, deep crustal melting, and slowly building pressure. But the resulting destruction? That's driven by raw, explosive planetary energy that causes an instant, catastrophic change to the landscape. And the effects don't just stop at the base of the mountain. The destruction elements actually include injecting millions of tons of sulfur dioxide aerosols straight into the stratosphere. That can reflect sunlight and literally cool the entire planet's climate for years. So you can draw a direct line from the silent science of the Earth's crust to the terrifying, far-reaching reality of an eruption. It ultimately comes down to this core truth right from our source material. Inside the world's deadliest volcanoes, we must learn how these powerful formations form and the destruction they can cause. It's a simple, direct statement, for sure, but it perfectly encapsulates their unstoppable, awe-inspiring nature. We study their formation, we track the seismic tremors and gas emissions, all because we absolutely must respect the profound destruction they are capable of. At the end of the day, knowledge is the only defense we have against geological forces that we can neither control nor outrun. We've seen the science, we've understood the massive scale, and we've contrasted the slow formation with the rapid devastation. But remember, the Earth is still active right now, right beneath our feet. So if they are this powerful, what destruction will they cause next? It's a sobering reminder of our fragile place on a geologically active planet, and a really powerful reason to keep learning, keep observing, and keep respecting the deadly giants that share our world. Thanks so much for joining me for this explainer, and I'll catch you next time.